Hello students. So in the previous video we discussed about the electrochemical cell. So once more just listen to here. So here zinc is dipped in Zn2 plus, then Cu is dipped in Cu2 plus. Zinc and copper are connected by a galvanometer or ammeter or voltmeter, anything, and salt bridge will be there. Okay, now need to represent the salt bridge here. So how can we represent a cell? Here anode reaction is there, Zn gives Zn2 plus plus 2 electron. Cathode reaction is here, Cu2 plus plus 2 electron gives Cu. When we combine anode and cathode reaction, we will get the overall cell reaction here. So if this is called as a cell, so if this is a cell, this will be one half cell, this will be another half cell. So this is a half cell and this reaction is a half cell reaction. This is another half cell and this reaction is another half cell reaction, and this is the overall reaction. We can call it as cell reaction. Clear? So this is the overall cell reaction. By using cell reaction, we can easily represent the cell. How can we represent this cell? Just look into here. Here, just look into the picture. Here zinc is dipped in Zn2 plus. Zinc is dipped in Zn2 plus. This Zn2 plus is connected by a salt bridge to Cu2 plus. So here importance is given to Cu2 plus. Inside this Cu2 plus, Cu is present. So zinc N Zn2 plus. So I can write zinc bar Zn2 plus. This Zn2 plus is connected to Cu2 plus using a salt bridge. So by using a salt bridge, so this represents the salt bridge. So by using this salt bridge, Zn2 plus is connected to Cu2 plus. Clear? So Cu2 plus, again Cu2 plus, inside the Cu2 plus, Cu is present. So then again Cu. So this is the cell representation. So I am simply writing REPN, representation. So this is the cell reaction, this is the cell representation. Clear? So from the cell reaction, you should be able to find out the cell representation and vice versa. From the cell representation, you have to find out cell reaction. So how can you find out this type of things? That's the first thing. Here just look into here. Zn is there, Cu2 plus is there, Zn2 plus is there, Cu is there. So how can we represent these things? We can simply say that this part is oxidation half part, this part is reduction half part. So if I give this question and you have to find out the cell representation without drawing this picture, how can you find out? So just find out, first you have to think about which is the oxidation part and which is the reduction part. Here just look into here. Zn, what is the charge? 0. Here Zn, what is the charge? 2 plus. So 0 converted into 2 plus. So this is the oxidation part. So Zn bar, Zn2 plus is represented in oxidation half. Then represent the salt bridge. Again, which is the reduction part? Here Cu2 plus. 2 plus is converted into 0. This is 0. So here this is the reduction part. Cu2 plus into Cu. So Cu2 plus bar, Cu, reduction part. This is the overall cell representation. Clear? Now, instead of these things, some other liquids may be given. So I have already told that this is an example for which cell? Galvanic cell. So what is mean by galvanic cell? In a galvanic cell, chemical energy will be converted into electrical energy. How electrical energy is produced? Here 2 electron is moving here through galvanometer. So electrical energy has been produced. So by the chemical reaction, electrical energy is produced. So conversion of chemical energy into electrical energy took place. Hence, this is an example for galvanic cell. But here, if we use Zn and Cu as the electrodes and Zn2 plus and Cu2 plus as the electrolyte, this particular cell is called Daniell cell. So Daniell cell means, Daniell cell is an example for galvanic cell. The galvanic cell which uses zinc and copper as the electrode and Zn2 plus and Cu2 plus as electrolytes. are termed as Daniell cell. Okay, I think it is clear for you. So you should know what is Daniell cell. Galvanic cell, another name is voltaic cell, and another name is electrochemical cell. And how to represent cell, how to write the cell reaction, you should be able. And one more thing, electrode and electrolytes are separated by a single line. Salt bridge is represented by a double line, again single line. Suppose if we take gas, for example, hydrogen gas. So we are using hydrogen gas as electrodes. If we use hydrogen gas as electrodes, I can write H2 hydrogen gas bar H plus. Here this is a gas. So we should use, so how can we extract the electron from, if this is a gas, suppose if this is a gas, how can we extract electron from this gas? There should be a medium. So we should use some metals. Suppose, for example, I am filling hydrogen gas in this beaker. So here hydrogen gas is there. I want hydrogen to be act as an electrode, but it is a gas. So how can I extract the electron from the hydrogen gas? So I should use a medium. As a medium, I am using platinum electrode. Clear? To extract electron from the hydrogen gas, I have to use platinum as the electrode, because platinum is less reactive. One of the least reactive metal is platinum. So platinum will not do any work during this reaction. So if the electron is present here, it will be from hydrogen, not from platinum. So I can simply use inert electrodes such as platinum to obtain electrons from the hydrogen gas. So here actually hydrogen is the electrode, but platinum is also present. Platinum is the medium which is used to extract the electrons. So I can write platinum in before hydrogen gas, Pt, H2 bar H plus. Clear? So if we use metal along with gas, this should be separated by a comma, platinum, H2 and H plus. Okay, I think it is clear for you. And one more thing, this is oxidation half. So what is meant by oxidation half? It is anode and this one is cathode, and in between these two salt bridge is there. So A, B, C is the order: anode, bridge, cathode. A, B and C. Okay. Now the next thing we have to discuss is, if I keep a voltmeter, so instead of galvanometer here, it will give the voltage of the total cell. That voltage means here one potential is there, here another potential is there. So higher potential minus lower potential means potential difference. So if I keep voltmeter here, it will give the value of potential difference in between cathode and anode. Okay, always cathode will have the higher value. So higher potential will always for cathode. So potential of cathode minus potential of anode will give the potential difference in between these two. So potential difference of the cell is equal to potential difference of cathode minus potential difference of anode, which will be given by the voltmeter. That means I can simply represent E as the potential, that means EMF. So potential, cell potential E cell is equal to potential of cathode, which is higher value, minus potential of anode. But these potentials will depend upon the temperature, pressure, etc. So if these factors changes, this potential also changes. Clear? So we have to use one more thing, E0 cell. What is meant by E0 cell is, if we represent 0, e raised to 0, it represents the standard state. Standard state means there is a set of conditions like 1 atmospheric pressure, 1 molar concentration, 298 Kelvin, etc. So this set of menu card, this menu card is called as standard state. That means anything if I take in this condition, I can say that is in standard state. That means if I take 1 atm or 1 bar, approximately it is equal to 1 bar, actually it is 1 bar. So if I make a condition 1 atmosphere pressure, 1 molar concentrations and 298 Kelvin pressure, I can say this is not voltage at standard state. So that condition is called standard state. So if I keep these states here, instead of E cell I can write E0 cell. So if E cell is the electrode potential, cell potential, if E cell is the cell potential, I can say E0 cell is the standard cell potential. Clear? Standard cell potential. So E0 cell means standard cell potential, where E cell is the cell potential. E cell means at any condition other than standard state. E0 cell means at standard condition the value of cell potential. Clear? It will be universally 1. There will not be any change in the standard cell potential values. So E0 cell is equal to E0 cathode minus E0 anode. This is the equation. So if the cell potential is equal to cathode potential minus anode potential, the cell potential at standard state, standard cell potential is equal to standard electrode potential of cathode minus standard electrode potential of anode. Clear? These two reactions are very important. So standard condition is one of the very important factor. So if I take zinc, I can represent what is the value of zinc. Listen, here E0 cathode is there. Here what is the cathode? Cu, which is anode zinc. So simply I can write E cell is equal to, for the particular reaction, this one, E cell is equal to E cathode minus E anode. This is the equation. So here, which is the cathode? Cu and Cu2 plus. So I can write E Cu2 plus bar Cu minus E Zn2 plus bar Zn. E cell is equal to E Cu2 plus bar Cu minus E Zn2 plus bar Zn. E cell is equal to E cathode minus E anode. Cathode is copper, anode is zinc. So we should write in this particular way. Clear? Now if I write E0 cell equal to E0 Cu2 plus bar Cu minus, what will be the value? E0 Zn2 plus bar Zn. Clear? So these two points are very important. Now, so you should be able to write E cell values for this one. So how can we calculate these values? These values in the standard conditions, values will be constant because the condition is already fixed. So at this condition, value of E0 Zn2 plus bar Zn is equal to minus 0.76 electron volt. Similarly, E0 Cu2 plus bar Cu value is equal to plus 0.34 electron volt. Clear? These two values are constant. Similarly, hydrogen. For hydrogen, E0 values will be equal to 0. So for hydrogen, the electrode potential will be 0. For zinc, minus 0.76. For Cu, plus 0.34. Standard state. Clear? So I can write for a Daniell cell. For a Daniell cell means zinc and copper used as electrode. For a Daniell cell, E0 cell is equal to, E0 Cu2 plus bar Cu minus E0 Zn2 plus bar Zn. It is fixed. So instead of E0 Cu2 plus bar Cu, I can give plus 0.34 minus E0 Zn2 plus bar Zn. It is already having a negative. So minus 0.76. Minus and minus will become plus. So it will be an addition. So I will get 1.1 volt or electron volt. is the answer. So for a Daniel cell, the E0 cell value will be 1.1 volt. That means if I take this thing, this is a Daniel cell, listen, but it is in some other conditions. The temperature may be 300, 350 or like that. So if I take 298 Kelvin temperature, 1 bar or 1 atmosphere pressure, 1 molar concentration of Zn2 plus, 1 molar concentration of Cu2 plus, that means standard condition. At the standard condition, this voltmeter will read the value of 1.1 volt. That means the potential difference in between these two, this one minus this one, will be 1.1. Clear? At standard state only. If the standard state changes, that means temperature become 350 and pressure become 1.5 bar, like that, this value will be changed. Clear? So for standard state it is constant. So you should study some values of electrode potential at standard state. You have to by heart some values because it is very important for the entrance examination. There is no other way than by hearting these things. So that we can discuss later. So now you have to know about zinc and copper and hydrogen. It is very important. For hydrogen it is easy to remember. It is 0. Zinc negative minus 0.76. For copper it is plus 0.34. Okay. So make it by heart now itself. So here one question is there. We should have to discuss about the question part here. Simple questions. So PT bar Fe2 plus comma Fe3 plus salt bridge MnO4 minus Mn2 plus H plus PT platinum. So we have to write the cell reaction using the cell notation. So here the question is write the cell reaction. This is a simple level question. Will not be asking for examination, but as a part of some other questions you have to find out the answer. So how can we find out? So first just check. Cell reaction means anode reaction will be there, cathode reaction will be there, and the overall reaction. They are asking about the overall reaction. So first check what is anode. What is anode? Anode means oxidation part. We know this is the oxidation part. Anode. A, B, C is the order. So this is anode, this is cathode, this one is bridge. So in anode oxidation take place. Always oxidation take place. Oxidation means increasing in oxidation number. That means which is the anodic part? Fe2 plus comma Fe3 plus is the anodic part. Is it? So this is the anodic part. Which is the cathodic part? Cathodic part is the MnO4 minus comma Mn plus is the cathodic part, and this platinum is a mediator. Similarly, hydrogen gas is also present, but actually the electrodes are these two. Salt bridge is surrounded by the two electrodes. So manganese and iron are the electrodes. Solution of iron and MnO4 minus, like KMnO4, like that, liquids are electrolytes. So first what I did, anodic part and cathodic part were separated. How? This is the oxidation half, this is the reduction half, this is anode, this is cathode. A, B, C. This is anode, this is cathode. Now in anode oxidation take place. Clear? Inside anode oxidation take place. Oxidation means always Fe2 plus should be converted into Fe3 plus. Otherwise if you write Fe3 plus gives Fe2 plus, it will be reduction. So write Fe2 plus will give Fe3 plus. Is it? Okay. Now only it is oxidation reaction. Clear? Sometimes the questions can be reversed. So think properly. Fe2 plus gives Fe3 plus. Now is it balanced? No, because it is 2 plus, this is 3 plus. To balance, here we should add one electron. Now only charge get balanced. 3 plus, 1 minus, 2 plus. Overall 2 plus, here also 2 plus is there. Clear? Now, which is the cathodic part? The cathodic part is MnO4 minus. Clear? MnO4 minus and Mn2 plus. How can we write the cathode reaction? Can we write MnO4 minus gives Mn2 plus, or Mn2 plus gives MnO4 minus? Which is the exact reaction? We should know this is the cathodic part. In the cathodic part, reduction take place. Clear? Just look here. What is the charge of manganese? It is 2 plus. Here, what is the charge of manganese? In the previous year, we discussed how to find the oxidation and reduction values, numbers here. Here, in MnO4 minus, manganese is in +7 oxidized state. If you don't know how to find the oxidized state, just ask me, I will explain, because in the previous year we have discussed more about this thing. So here Mn is in +7 oxidized state. So here also Mn is in +7 oxidized state. Now check which is the reduction reaction, this one or this one. Always this is the reduction reaction. So this is correct and this is wrong. So this is the exact cathodic reaction. Now I can write cathodic reaction means MnO4 minus gives Mn2 plus is the reaction. But here H plus is also present. Why H plus? In the previous year we have discussed how to balance the redox reaction in a proper way. So this is the anodic reaction, this is the cathodic reaction. How can we balance? Here one electron is there. Here how many electrons should be there? Look, MnO4 minus means Mn is in +7 oxidized state. So here how many electrons should be used? 5 electrons should be used. So to balance the reaction, I have to write 5 electron here and balance both in acidic or basic medium. Here we have to discuss acidic medium. So in acidic medium, on balancing, how you know how to balance the redox reaction? You should study. If you don't know, just check the previous NCERT textbook. Otherwise, I will explain later. Now, how to balance these reactions? 5 Fe3 plus MnO4 minus plus 8 H plus gives 5 Fe3 plus Mn2 plus is here and 4H2O is there. In the previous year we have discussed the same question. So just check the previous year's note also. It will be there. Otherwise we just look into the NCERT textbook. It's also there, I think. In NCERT book it is there. Anyway, after balancing we got the overall reaction. Okay, so this is one of the very important part. We will discuss more questions. So if you didn't understand these things, again see the video, and if you have again doubts, you just ask me personally or in this way. There will be a doubt clinic, so we can explain. I think these things are clear for you. Now next question is one more question I will discuss it. Second question, Pt bar H2 gas is there, comma H plus is there, salt bridge is there, Ag plus bar Ag is the cell representation. We have to make into the cell reaction. That means anode reaction, cathode reaction, overall reaction. How can you calculate? Try to get the answer. Just pause the video and try to solve as I solved did in the previous question. Okay. Okay, now you know. First what we have to do, which is the oxidation part? This is the oxidation part. Which is the reduction part? This is the reduction part. Oxidation half is there, reduction half is there. So here oxidation should take place. Look into the charge. Here it is 0, here it is +1. So H2 gives H plus. Now oxidation took place. 0 converted into plus 1. So this is the oxidation half. Clear? Now is it balanced? It's not balanced. So how many electrons should be there? Here elements also not balanced. Here H2 is there. Here only one H plus is there. To balance, I have to write 2 H plus 2 electron. Then only get balanced. Clear? So now atoms are balanced. Charge is also balanced. Here 0 charge is there. Here 2, 1 plus, 2 pluses are there. So to cancel, 2 electrons should be added. So this is the oxidation half or anodic part. Now, which is the cathodic part? Ag plus and Ag. How can I write? Here, reduction take place. Reduction means plus 1 should be converted into 0. So I can write Ag plus gives Ag. This is the reduction part. So is it balanced? It's not balanced. Here how many electrons should be added? 1 electron should be added. So I will get Ag. Clear? Now, is it balanced now? No. Here 2 electrons are there. Here only 1 electron is there. To balance, I have to make this into 2 electron. Then only these two get cancels on adding these two. So how can I balance? Multiply this reaction with 2. 2Ag plus gives 2 electron 2Ag. Now this will get cancelled on addition. So addition, I wrote that gives H2 plus 2Ag plus 2 electron gives 2H plus 2 electron plus 2Ag. This is the reduction part. Okay. 2 electron got cancelled. 2 hydrogen are there. 2 hydrogen is there. 2Ag is there. 2Ag is there. 2 plus charges are. 2 plus charges are. All charges are balanced. No need to balance in acidic or basic medium. It is easy to balance. So here balance equation we obtained H2 plus 2Ag plus gives 2H plus 2Ag is the cell reaction. Clear? So these are the things we have to discuss more. It is not completed. Anyway, in the coming classes we will be discussing more. So watch carefully. This is one of the very important and one of the confusing chapter. So we should get an idea. So through video, the conveying the ideas are there are many limitations. So if you have any doubt, just write it in your notebook and ask me during the proper time. Okay. So all the best and study well.